So polynomial sign charts. We'll do these with more than just polynomials, but we're going to look at sign charts and inequalities. Again, super, super important and really pretty easy. So this says, so we're talking about positive and negative intervals, which we've already talked about, but it says, given a polynomial function, a polynomial inequality has the general form of, we've got greater than or equal to, not equal to, less than or equal to, basically everything that's not equal, hence the name inequality. So if the inequality, if f of x is greater than 0, that's true when f of x is positive, because that's greater than 0, right? What does f of x represent? Y. So what that's saying is when your y values are positive, okay, just remember f of x, that's your y values. Then if inequality f of x is less than 0, that's when f of x is negative. That should be a no-brainer for you, I hope. Okay. So then we are given a function. We're given the function, we're given the graph, and we are told to name all the intervals for which f of x is greater than 0. So that's what we're looking for when it is positive. So my graph is positive here, here, and here. It's when my y values are positive. Remember, we're talking about y, but we are writing about x. So the intervals we write are intervals of the domain, even though we're looking at when y is positive, okay? So since this part is positive, it starts way out here on the x-axis at negative infinity. And then it remains positive until we get to negative 3 on the x-axis. Then it starts back over, and I don't include it because that's when it is 0, right? I don't want to know when it is 0, just positive or negative. So then I start back over at negative 1, and it's positive until we get to 0. And then I start back over at 1, and it's positive until we get to infinity. Okay, that look familiar? It's like I said, we've already covered this once. Then I want to name the intervals for when f of x is less than 0. That's when it is negative. So it is negative here and here. So you go ahead and write the intervals for when it is negative. And it should look like that. Do we agree with that? Easy enough? Okay, awesome. Because that, like I said, is a total review. Okay, so let's talk about the steps for a polynomial sign chart. I'm going to talk you through the steps, then we're going to actually do them, but then they'll be written there if you need to go back and think about what you didn't do. So you have to set it equal to 0, which is super easy. We completely factor the polynomial and find its zeros. We can totally do that. We plot the zeros on a number line. We can totally do that. Choose test points in each interval and substitute. So I'll show you how to do all that. And then we shade the sign chart above and below according to the signs. All right, so let's look at number 1. I've got some extra lines after the 25 for no good reason, but I've told you before my fraction bars disappear a lot. These are probably some that ran away and ended up here. I don't even know where that came from. So there's my polynomial. I'm supposed to set it equal to 0 and factor. So I'm going to kind of do that all in one step here. So this 0 equals, and then a is 1 here, so I can go ahead and jump to this. I have x squared and x squared. The signs are the same because that's positive and they're both negative. So two numbers that multiply to give me 25 combine to give me negative 26. 1 and 5. Yeah, and 25. Good. All right, can I factor this more? Yes, I can. So 0 equals x plus 1 times x minus 1 times x plus 5 times x minus 5. Or some other order of that is totally fine. When we write our zeros, it is a plus or minus, but in this case, I'm not going to do that because I want them actually in the exact order that will help me on my number line. So my smallest x is negative 5, then negative 1, then 1, then 5. Oh my gosh, can't even write the right thing. Thank you. Okay. So now I'm going to plot these on the number line. So the number line really represents my x-axis. We just don't really care about the y-axis yet, or right now. So this is just the x-axis, basically. So I've got a -5. I'm not going to put a bunch of hash marks because I'm not actually graphing. I'm just going to kind of space them out, you know, to what would sort of make sense, like that. And then these are points, so I'm going to plot my points here. Okay, because this is when the graph is 0. What we want to figure out is when is it positive, when is it negative. So to do that, we're going to use our fully factored form right here. So remember, this is factored, but this is fully factored. And we're going to pick a test point. Okay, and I think y'all picked test points when you were doing inequalities before. I know this isn't an inequality yet, but still same type of thing. I don't care about the actual value. We're not going to be multiplying numbers. All I care about is it positive or negative? So if I pick a number between -infinity and -5, I don't have to go crazy. I can pick -6, okay? When I substitute -6 into here, I would get a -5. Again, don't care about the 5. All I care about is that number would be negative. I substitute the -6 in here, I would still get a negative. I substitute it in here, I still get a negative. I substitute it in here, oops, I still get a negative. So whatever the numbers are, because I don't care about the actual value, in the end, when I multiply all 4 of them together, I'll be multiplying negative times negative times negative times negative, which is positive overall. Okay, does that make sense? So I know between -infinity and -5, my function's positive. That's what that tells me. So I do it for each little set. So between -5 and -1, I'll choose -2. I substitute it in here, it's still negative. I substitute it in here, it's still negative. Substitute it in here, positive. In here, negative. So when I multiply all 4 of those together, it's negative overall. Between -1 and 1, I can choose 0. So if I can choose 0, I choose 0. That's definitely easiest. So when I substitute in here, I'll get positive, negative, positive, negative. When I multiply all that together, it's positive. Okay, everybody understand where my positives and negatives are coming from? Any questions at this point? Okay, so then between 1 and 5, I'm going to pick 2. So this will give me positive, 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 then negative. So that's negative overall. After 5, I'll pick 6. So that's positive, 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 positive. And then that is positive overall. All right. Then the last step of this is to shade. So I've said that this is positive overall, so I'm going to shade above my x-axis. This is negative, so I shade below my x-axis, then above, then below, then above. There are times when you're applying this stuff, and I know in here we don't apply it nearly as much as you do in calculus, because in here we have to kind of learn how to do some stuff so you can do that. But there are times where you don't care about the zeros or anything. You just care about when is the function positive and negative, and this tells us that, and this will help us a whole lot. It'll help us in the next thing we're graphing as well. Okay, any questions at this point? All right, so let's do number 2. Number 2 is already factored for me. That's great. So I was supposed to set it equal to 0 and then find my x's. So here, 0. There we go. Then find my zeros. Okay, so I'm going to have a 5, a 1, and a -3. So that'll be -3, 1, and 5. And they gave me the fully factored form, so I'm not going to have to factor it at all. So I'm going to put my -3 on here, my 1, and then my 5 maybe right about there. Plot my points. Okay. I'm going to substitute in, let's start with -4. So -4 in here will give me a negative number. -4 in here will give me a negative number. -4 in here will give me a negative number, but then I square it, so it will be positive, right? So whatever I put in that third parentheses, I'm going to square it every time, so it's going to be positive every time no matter what happens. Does that make sense? All right, so this is positive overall. You finish up that sine chart. See if you can finish that up. What's your question? Did you get it answered?
What number?
Well, any number between -3 and 1 doesn't matter. So I would pick 0 because you can pick 0 in there. So you just pick some number in between there. Doesn't matter what it is, and then pretend like you're substituting it in. So if I put a 0 in there, it'd be negative. 0 in here would be negative. 0 in here would be positive. There you go. Okay, thanks. And then here, I would probably pick 2.
So I don't get it. Like, okay, I guess I have it given, but when you get the negative and positive, how come this won't be negative? Or this one won't be negative?
Because negative times negative is a positive,
Oh,
and then
I forget
positive.
about that.
Yeah.
Darn.
Can't forget about that. All right, so do y'all agree with my signs here? Okay, so I've got positive, positive, negative, positive. So if you were thinking on the first one, oh, they just alternate. If they just alternated every time, then we would just pick the first one and know that they alternate. That's not what happens every time, okay? But there are things that we do know that the sign chart also tells us. So if we look back at number 1, if we hadn't done any of this stuff, based on what you know about polynomials, because we've sketched them, if I'm just looking at this, what does the end behavior look like? Up, up, right? Because it's even and positive. Well, look at what's happening on your sign chart. It's positive on either end because your end behavior would look like that. Make sense? It's the same thing. So when I look at number 2, what would this end behavior look like? Up, up, right? This one's up, up also. Also, what else do you know about this graph when you graph it? It's going to bounce. It's going to bounce because we have this 2 right here, so it bounces at the -3. That's why this repeats. I can sketch my polynomial just from the sign chart because the sign chart basically finds all the stuff that we had already found except for the y-intercept. So if I know that I start up, well, even if I didn't know that, this is positive, so I have to start up here, and then I have to stay positive, but I have to get to 0. So I'm going to come here, I'm going to bounce, I'm going to go down here, and then come back up. Whoops, dang it. Sorry, leaning on the board again. Come down here and come back up. So my end behavior is up, up, and I have a bounce there. And that's what happens from the sign chart, okay? What questions you got? All right, good deal. So let's look at the next one. So on here it says, sketch the graph of the polynomial with the x-intercepts and the signs from the sign chart. So positive, negative, positive, negative, positive. Then the numbers are, let's see, this is -6, -4, -1, and 1. Y'all agree with that? Because they kind of look like blobs up here. All right. So then on here, I'm going to sketch that. I have to go to -6. So we'll go 1, 2, 3, 4, 5, 6. It's fine. 1, 2, 3, 4, 5, 6. Maybe you could get 7. I just didn't space mine right to do that. And then I'm going to plot my points. So I've got -6, -4, -1, and 1. And I can sketch my polynomial from this. The only thing I don't know, because before I didn't know my maximums and minimums, but I also don't know my y-intercept, and that's okay. I don't have that information, so I can't use it. And so when I sketch, I know I'm up here. My end behavior looks like this for sure. So I start up here. Do I bounce anywhere? No. So I start up here, and I'm just going to go back and forth through my points like so. And again, no idea where my maximums and minimums are, have no idea where my y-intercept is, but that's your basic sketch of the polynomial. Okay. What questions you got? All right, you try number 4 on your own. The other thing that the sign chart doesn't tell us is if we have a point of inflection or a wiggle, okay? But again, that's okay, because if all we care about is positive and negative, then that doesn't really matter anyway. But do I have a bounce here? Yes, and I bounce where? At 3, okay? And this is negative, so I know my end behavior looks like this, right? So I start down here, and I'm just going to pass through these till I get here, and I bounce, and it comes back up, and it should look something like that. Joelle, ask me a question because you're looking at me like I'm crazy. Because it's negative, I have a 0 and it's negative again. So it's negative, I have to hit the 0 and then I have to be negative again. So anytime these repeat next to each other, because I have to hit the axis at those points because that's when it's 0, okay? Now, on Delta Math, you're going to be sketching these. So I'm going to erase this and then do it wrong, and then I'll put it back on here correctly. One of the things, because I know that some of you were frustrated because you were like, I know I'm doing it right. I know my numbers are right. First of all, as long as you're really, really close, it is very forgiving. But if you do something like this, oh, shoot, hang on, I did it. You do something like this, if you're off a little bit, it should snap it to it and you'll be fine. The problem is you can't hook back either way because then it's not a function. And that's most likely the problem if everything else is correct. So make sure it doesn't really go out like dramatically, but you may need to make it a little bit, I mean, not super dramatic, but just make sure that you're coming in at the correct angles here and that you're shooting that way, or straight up is fine, but don't hook it back the other way. Oops. And it is easier, I think, with a real mouse instead of your trackpad mouse, and you're welcome to borrow those if you need to. Did you have a question? You won't from the sign chart. You would have to know from the function. So if all you're given is a sign chart, you won't know if it's a point of inflection, and that's okay right now. Okay. Oh, there could totally be, because you don't know what the actual equation is. And so this could actually represent a few different equations, because maybe this is a point of inflection right here, because this is x minus 1 cubed. Or maybe it's just x minus 1. Like, you don't know, and that's okay right now that you don't know that. Okay? Good questions. Anything else? All right, so now let's look at the inequality part of this. So the steps are basically the same. We use steps 1 through 5, which is basically everything that we did. But for step 3, we have to pay attention to open, close points depending on the inequality, since it's an inequality. And then we have to write the solution to the inequality. So our first step was to set this equal to 0. And this is not set equal to 0, so I need to do that. So I'm going to move my 10x squared over. So I'll get x to the 4th plus 4x cubed minus 9x squared minus 36x, and that is greater than or equal to 0. Okay, so now it's set equal to 0. Then I need to factor it. Is there a GCF? Yes, you always ask yourself that question first, because some of you don't do that, and then you make your life really hard. So x times x cubed plus 4x squared minus 9x minus 36 is greater than or equal to 0. Okay, so now I want to factor this. I'm going to factor by grouping. So I get x times x squared times x plus 4. I can factor out a negative 9. Leaves me with x plus 4. That's greater than or equal to 0. So then I get x times x plus 4 times x squared minus 9 greater than or equal to 0. Can I factor more at this point? Yes, I can. So x times x plus 4 times x minus 3 times x plus 3 is greater than or equal to 0. So that is my fully factored form. From that, I get my zeros. Let's see, my smallest one will be -4, then -3, then 0, then 3. So these are the two parts that I look at to help me with my number line. So I will have -4, -3, 0, and 3. Still not super to scale, but I want to leave myself a little bit of room here. So opened or closed circles? Closed, okay, because it's then equal to. So closed circles here. Then I'm going to choose my points. So I'll choose a -5. When I substitute it in here, I will get negative, then negative, then negative, then negative. So that is positive overall. Okay. Negative, I'll use negative like 3.5 here. That would give me negative. That's still negative. I'm sorry, that would be positive. Duh. Negative 3.5 plus 4 would be positive, and then negative, negative, negative overall. I can't use 0, but between these two, I can use -1. So that would give me negative, positive, negative, positive. That's positive overall. Okay, y'all do the last two. Do we agree with that all right? Yes? So this is positive, negative, positive, negative, positive. So then I'm going to use that to write the solution to this. So the inequality says the function, I want the function when it is greater than or equal to 0. So are we looking for positive or negative? Positive. It's positive plus 0 because it's greater than or equal to. Okay, so being 0 is okay here. So that means that this is positive, so I start out at negative infinity. I never include infinities. I'm positive all the way to -4, but since I can include 0, I include the -4 this time. Then I union that. I'm positive between these two again, between -3 and 0, but because being 0 is okay, I include them. And then I start back over at 3 and go to infinity. Never include infinity, but I do include 3 because I have closed circles there. This is the solution to the inequality. Okay. What questions do you have? All right. So let's look at number 6. I got to set it equal to 0. So that will give me 3x to the 4th minus 11x cubed minus 4x squared is less than 0. So I need to factor this. What do I do first? GCF. So I factor out my x squared. That leaves me with 3x squared minus 11x minus 4 is less than 0. So you go ahead and factor, find your zeros, do your sign chart. When you get to your sign chart, are your circles going to be opened or closed? Open, because this is less than. Okay, good. I'll give you a minute to do that. when you're dealing with that negative 1/3, you don't have to get crazy over here. I would just pick -1. That's what I did. But then between negative 1/3 and 0, you do have to figure out a fraction that's between there correctly. I used -1/4. But this is what we get. We have to write the solution to the system, and this is less than. That means we want it when it's negative, but it can't include 0, okay? Because it's not less than or equal to, it's just less than. So it's just these two pieces. So I'm going to go from -1/3 to 0. I do not get to include them because I don't want my function to be 0. Then I go from 0 to 4. Now, had this said less than or equal to, then being equal to 0 would be okay. So I could have included 0, -1/3, and 4. So I could have written it as one interval and been fine. Okay, one full thing there. What questions do you have? Anything at all? All right, awesome.